From what we were given, from the question given, we were asked to what? They said we should calculate the specific what? The specific weight, the specific mass, the specific what? Volume, and specific what? Gravity of a liquid having a volume of 6 meter cube. So the first thing you should underline is we are talking about liquid, not gas. That's the first thing. Now, what are we seeing? We are seeing the non-parameters. So what you do is you use your known parameters to calculate for our unknown parameters. And what are our unknown parameters? Specific weight, specific mass, specific volume, and what? Specific gravity. So the first thing you do is you bring out your data, bring out your given data. From your question, we are given volume, right? So we have volume of what? 6 meter cube. What next are we given? We are given weight. So we have weight, and they said, what's the weight? The weight is what? 44 kilo Newton. They give us gravity, and they say your gravity is what? 9.81 meter per what? Second square, right? What are we giving? We are also giving specific weight of water. So what is that telling you? That's telling you that when you want to calculate for your specific gravity will basically be what? Specific weight of liquid divided by the specific what? Weight of water, right? So if we were to calculate for specific gravity, this is what the formula you are to apply. Am I communicating? Now, since we've been given what? Gravity, and we've also been given what? Specific weight of water. So you can take down your specific weight of water, or water as the case might be, will be equal to what? 9.81 kilonewton per meter cube. I told you that what you have here is always a constant that will be given to you in your question. If you are not given in your question, then you should take it in, just have it in mind that your specific weight of water is what? 9.81 kilonewton per meter cube. Now, what's the first thing we're asked to calculate for? Now we're asked to calculate for your specific weight. Specific weight. So now to calculate for your specific weight is equal to the product of what? The product of what? Weight with respect to what? Volume. That's what we use to calculate for specific weight. And from what we have here, we can see that what's our weight? The weight that was given to us in our question was what? 44 kilo Newton. So we have 44 kilo Newton. Your units are very important, so you always include your units. Divided by, what's the volume? The volume is 6 meter cube, so we have 6 meter cube here. Now if you punch your calculator, this will simply give you what? 7.33 kilo Newton meter. So we have 7 point what? 333 kilo. What's the unit? Newton per meter. Now, what do? We have kilo here. Convert this to what? Newton meter. Removing the kilo. What do? You simply multiply by what? 1000. So you basically have this to be 7 point what? 333 times what? 1000. And if you do that, you simply have 7333 Newton per what? Meter cube. So this is your cube. So we've succeeded in calculating for our specific weight, right? Now, what's the next thing which we are asked to calculate for? We are now asked to calculate for your specific mass. Your specific mass, or your what? Your mass density. For you to calculate for your specific mass, we said that for your specific mass is denoted by what? Small m, right? And we said small m is what? Mass over volume, right? So in essence, well, I also told you that your specific mass can also be denoted as what? Density symbol, right? Now if your your specific mass can be denoted by this, It's telling you that anywhere you see density, density is the same thing as what? Specific mass, or what? Mass density. Am I communicating? Now go back to our question. Looking at our question, are we giving mass? No, we are not giving mass, right? So what do you think you are going to do to calculate for your specific mass? Remember, when we talked about specific weight, I brought out a formula that says what? W is equal to density multiplied by what? Gravity. Now, from what we have here, we can see that if you divide here by gravity, you divide here by what? Gravity, you simply have that density will now be equal to what? Weight over gravity. But remember, what is now density here? Density is the same thing as what? Specific mass. Am I communicating? So if we have that, this will simply give you what? What's now your W? Remember, the W was the specific weight which we calculated for. And we said our specific weight is equal to what? Our specific weight was equal to what? 733 Newton per meter cube. So what do? You impute that value into this equation. So you have 7333 divided by acceleration due to gravity was given to us in our question. And what is it? Acceleration due to gravity was basically what? 9.81 meter per second cube. So you come down to your question and you impute the value for acceleration due to gravity to be what? 9.81 meter per second square. Here you now have Newton per meter cube. Don't forget putting the values. Now, what you simply do is you punch 77333 divided by what? 9.81 in your calculator. Now, if you punch that, you simply arrive at, this will simply give you what? 747.50. And what's the unit? What will be the unit? Remember, mass is measured in what? Kilogram. Volume is measured in what? Meter cube. So what you have here will simply be what? Kilogram per meter cube. Am I communicating? And that will be the unit. Sorry, I should put it down. So this will give you, this will be 747 point what? 50 kilogram per meter cube. So this is your specific mass. What's the next thing from our question? The next thing which we were asked to calculate for was specific volume, right? Specific volume. How do you calculate for your specific volume? Remember, when we talked about specific volume, we said specific volume is equal to volume over mass, right? This was specific volume. We said specific volume is equal to volume over mass. Now, looking at what we have here, can we see mass? From our question given, we've not succeeded in what? Calculating what mass is, right? Now, what you simply do is, remember, when we are talking about specific volume, I also told you that your specific volume can be represented as what? Small v, or 1 over what? Density. So what you do is, you simply take, but we know what density is, right? Density is basically what? Specific mass. Now, what's your specific mass value? 747.50. So what you do, you simply come down and write your specific volume will now be equal to 1 divided by density, which is what? 747 point what? 50, right? Now, if you punch this in your calculator, this will simply give you what? 1 point what? 34 times what? 10 raised to the power of what? Minus 3. What's the unit? Remember, this is measured in what? Meter cube. And this is measured in what? Kilogram. So the unit will simply be what? Meter cube per what? Kilogram. So this is the answer for your specific volume. Am I communicating? Now, what's the last thing which we were asked to calculate for? We're now asked to calculate for specific gravity of a liquid. Now, what will be the specific gravity of the liquid? Remember, I told you that from what you have here, since we are considering liquid, and we are also considering specific weight, we are now going to apply the formula. Specific gravity will be equal to what? specific weight of liquid divided by what? Specific weight of water. Am I communicating? So your specific gravity here, specific gravity of the liquid will now be, remember what's now the specific weight? We talked about weight, specific weight of liquid, right? Divided by specific weight of water. Now, remember we've calculated for the specific weight of liquid and we said from what we have here, the specific weight of liquid was what? 7 point what? 333 kilonewton per meter cube. So you pick down your specific weight into this equation. So you have 7.333 kilo Newton per what? Meter cube divided by specific weight of water was given to us in our question. And what was that? Look at our specific weight that was given to us. So we have 9.81 kilo Newton per meter cube. So you impute that into this equation. So you have 9.81 kilo Newton per what? Meter cube. Now, what do you simply do? You simply punch this in your calculator. Now, if you punch this with your calculator, you simply have this to be 0 point what? 7475. Now, remember, you ask yourself, what is the unit for specific gravity? Look at what you have here, kilonewton per meter cube, kilonewton per meter cube. So both of them will simply what? Wash out, and you'll be left with what? No unit. So your specific gravity of the liquid will now be what? 0.7475. Am I communicating? Now you've succeeded in calculating for your specific weight, your specific mass, your specific volume, and your what? Specific gravity of the liquid.